Okay, one is to think through a problem first. And you're looking at these things over here, and they certainly are related. One is the opposite of the other. And I hope you do realize that this one on its domain would always be positive, and this one on its domain would always be negative. And the domain of these things just goes between plus or minus one. So I notice that this over here is kind of restrictive. So what I want to do is, kind of draw, I'm not going to say a good picture, but good enough for me. So I'm going to look at this one first. I said it's positive, in other words, above the x-axis. If you start at 0, you get 3. And remember, say that the domain is between plus or minus 1, and when it approaches plus or minus 1, it's going to be asymptotic. So I'm going to say, something like this over here. Again, it doesn't have to be terribly accurate. What's this guy over here? It's just a reflection about the x-axis, something like this over here. All right, there's my rough picture. And these points over here, pretty easy to do, by the way. This is going to be, that point's going to be 0, 3. This point over here is going to be 0, minus 3. And what are we doing? We're doing a region of it. And this is the region we're doing between symmetric limits between minus 1/5 and 1/5. All right? Same thing, representative rectangle. What do you get over here? Let's write this down. And it's important you're able to set the integral up. I'm going to say it looks like it's going from minus 1/5 up to 1/5. Upper, this is the upper curve, minus the lower curve. Well, that's going to be 6 then, because it's going to be 3 minus 3, which is 6, over the root of 1 minus x squared dx. All right? Now, granted, I do know that a lot of times I'm looking at things and wondering, do I know that guy's antiderivative? Do I recognize it? And a lot of times I don't remember. I mean, I haven't seen them in a long time. I just don't remember those antiderivatives. And then I got to start playing around with saying, what else could I do? And then it might jog your memory if you play around with things. I often say a lot of times when you're thinking of words and you can't remember the word that you're thinking of, you just start going through the alphabet, like A, B, C, D. As you're doing it, though, you're thinking like A, the word might start with A, blah, blah, blah. But anyway, I think this is somewhat recognizable. So I'm going to say it looks like 6 arc sine. Now, again, if I couldn't remember that and I thought it was arc sine, what I would do is I would differentiate arc sine to make sure it gave me 1 over the root of 1 minus x squared. A lot of times I think I know something when I don't know it, all right? But anyway, what's limited integration over here? It goes from minus 1/5 up to 1/5. What's the next thing you're going to do? Let's take a look. You're going to plug it in, and let's write that down. And what do you get? You get 6 arc sine of 1/5, and then minus 6 arc sine. I'm going to write it a little differently. I'll write sine with the minus 1 on it, minus 1/5. All right? Now, granted, I realize, some people say, oh, there's all these tricks that you do, and I didn't know about that trick. You shouldn't be worried about that. What you left the answer looking like? And let me just make sure it looks a little bit neater over there. That's minus 1/5. All right? But anyway, what's nice about the arc sine function is I can probably simplify a little tiny bit, and I'm going to simply say this same thing as 6 arc sine of 1/5 plus 6 arc sine of 1/5. All right? All right. So what do we do now? I have to add that together. And what do you get over there? 12 arc sine of 1/5. All right? By the way, I would think this is also a good answer if you wrote that down. No objections at all. And I want to see if that answer is written down. I don't see that answer written down, by the way, but I do see this answer written down. Before I say anything, though, I do want to look at the work. And the work is what we said it was, all right? And we're getting this over here, all right? So I want to go through a couple things. And again, if you're fine with that, you don't have to listen now. I'm going to just talk about certain things at this point. And what I want to talk about, let me erase this business over here. I want to talk about if I couldn't really remember and I had the time to verify something, I would take that time to verify it. And what I want to verify the derivative with respect to x of the arc sine of x is equal to 1 over the square root of 1 minus x squared. So I want to kind of remind you what you did in the past, and let me go through that with you. So you would say, oh, y equals arc sine. Then you would say sine of y is equal to x. Then you'd say, oh, cosine of y, dy dx is equal to 1. And then you'd solve for dy dx. And what would dy dx be? I'm just reminding what you did in the past, by the way. It would be 1 over cosine y. All right? What do you get now? Well, let's just talk about the invertible region of the arc sine function. Really relates back to the sine function. And the sine function's invertible region looks like this over here, between minus pi over 2 and pi over 2. And what's interesting about that, the cosine curve is going to be non-negative there. So I'm not too worried about like signs of this thing anymore. So let me write this over here, 1. And I'll just do it like a really simple right triangle now. What's the angle going to be? X. I'm sorry, the angle's y. What am I saying? Let me get my eraser out again. The angle's y. I'm looking at this, by the way. What's the sine of y? It's x over 1. What's the side over here? It's 1 minus x squared. What's the cosine of y? It's the root of 1 minus x squared. We just verified this over here, all right? So again, if you can't remember something, it might be a good idea to have the ability to verify it. Let me erase that. All right, erase this over here. And let's see what else I can do. Right, another thing that, again, if you're tuned out by now, that's good for you. Let me erase this over here, erase this over here. And I said something kind of interesting before. At least I thought so. I was saying that the arc sine of minus 1/5 is the same thing as minus the arc sine of 1/5. All right. Now, do you want to maybe go through a couple different things with you about this over here? You know, odd functions. Let me go even functions. Even. What's an even function? Well, an even function would be like if you have f of x equals f to the minus f of minus x. That's even, right? And for odd, what do you have? F of, let's see, minus x. I think, you know what, I write down the way you were given to it, I think in Math 119. And you were told, let's see what you're told. F of x, and let me just review that with you. Odd functions are symmetric to the origin. You know, if this is x, this would be minus x over here. This is y, this is minus y. And you were told, you know, basically it's symmetric, so f of x would equal minus f of minus x, which is really what I'm seeing over here. All right, let me just go through that with you. So, you know, I have the f of x, which is arc sine. We'll talk about this being odd, by the way. They're claiming that this would be minus arc sine, it's odd, of 1/5. That's what they're claiming, all right? And that's what we wrote over there. So, you know, what do we do over there? We just kind of use that oddness of it. And, you know, someone says, how do you know it's odd? Well, let's go through that. The sine function's odd. We're expecting the other one to be odd as well. Thank you.